I want to ask you a question. If you work in a regular facility with an SDI crossbar router and you have a camera and you have a monitor, then you go and you route the camera to the monitor and the images appear on the screen on the monitor. Easy. If the camera has an IP connector on it and you plug it into an IT router and the monitor is a multi-viewer and you plug that into an IT router, where's the control panel? How do you make those connections? Arne, take it away.
Hello. Thank you very much, Brett. I'm Arne Boenninghoff from Real Communications, and I'm going to talk about connection management of essence flows, as Brett indicated. So what's the background of this? So as part of my work at Real, I do testing of our equipment with third-party equipment, and we go to interop events or pre-staging events like in Houston or in Wuppertal, what we did right now. And of course I support custom installations if there are IP questions. And what we see is all the essence flows are fine. So like John pointed out, the standards are all done, but the SDP exchange is mandatory by the standard, but how to exchange. And we heard that ISO 4 and ISO 5 are done, but not every vendor are doing it, and there's some resentments, and I just want to explain what we are doing here and what you also see right over there in the ISO 4 and ISO 5 demo. So what we have is we have different subnets in this room. We have the management network, the media network, we have an audio booth, and we have the ISO 4 booth, and we have a link to the Real booth over in the other hall, all connected, and it's all different subnets. So we have a routed layer 3 network, and in every network we have an ISO 4 registry. And I'm going to explain how this workflow is then going, how the nodes are registering. So, because the background is how do you find the devices so that you can connect them? First, you have to identify them in your network before you can then say, okay, sender A, go to receiver B. So each device in the network, which is following ISO 4, is creating a data structure that describes vendor independent, what kind of interfaces I have, what kind of senders or receivers I have, and what flows they are carrying. And they are looking for this registry with DNS SD. That's what John before said. And you can do it with multicast DNS, what we do here. So each subnet has its own registry, and they can find it with MDNS. Or we could reduce it to one registry if every device would implement the unicast DNS workflow. And then right now they look it up with MDNS and they find this registry because the registry is telling I'm here. I give you my IP address, and then all the devices are posting resources. And those resources, this is just an example, they are covered in a JSON object. So you have a node object, a device object, and a source object, sender object. There's different objects defined in the specification. And for example, in the node object, you have something that's not the right one, and it won't work. So you have an IP address, how to configure that device. You, of course, have the name, a description. You have a clock. Is it clocked to PTP? Which PTP domain is it running? And what interfaces does it have? So you could have a large video router with a lot of interfaces, and they all have different IP addresses and MAC addresses. And it's all information that the device will then push to the registry. And with DNSSD, on the other way around, any control system could then look for this registry and pull out the data. So it makes a GET, HTTP GET, and gets all the resources. Or it makes a WebSocket subscription and gets live updates. So if you unplug a device, it will get instantly notified. And then you can build a user interface which then lists you information. So here we have a user interface listing the Grass Valley camera with the capabilities it has, the different flows it offers. But how to get the STP file for the connection management? So if we look at the sender object, each sender object contains a link, a reference to the STP file. And this is how we can then, as a control system, pull the STP per each sender of the devices. And ISO 5 then solves the problem, how do I configure and connect senders of different vendors? So I have this STP file, but maybe I want to set the multicast address first. So like John described, we have a way to set the multicast addresses on the senders. So you don't have to go to vendor A's user interface and type in the sender's configuration and go to vendor B receiver, type it in. I want to have one central control system that maybe gives out all the multicast addresses to all the senders. So I go to the registry, I pull out my information, and I have my ISO 4 device. And here I see a link for the connection management API, which is ISO 5. And when I get there, I can do again HTTP GET and get the transport parameters, that's what they call. And again, it is a JSON format, so all standard IT technology, and it contains this critical information. So I have my destination IP, destination port, and the source IP. This is also critical when I have IGMP version 3 or source-specific multicast. I need also to know the source IP. And I see, is it active or is it not active? And I can also schedule an activation. So I could put a time in there and say this sender should be activated at 12 o'clock, for example, for an automation system. So I do a post or a patch to those parameters, and I set the multicast address for the sender, and the same I can do on the receiver's transport parameters. And then I can activate the sender, and the sender will stream out. But we have IGMP, so no one is receiving it, and I need to get the STP file. So I say, get the transport file, and I will get this STP, which I showed you before. And it contains all the additional information that are then flow specific. So for audio, I need to know how many channels I have, what's the packet time of this flow, and what's the PTP clock I'm clocked to. And for video, I need to know the resolution, I need to know the color space, and all that is contained in the STP. And this STP is actually mandatory in the 2110 standards in AES67, and this is then the standard way to get it if you implement ISO 4 and ISO 5. And what we see, ISO 5 describes how to exchange that, but we see that not all the STPs are compatible to each other. So we get an STP of vendor A and push it to vendor B, but the STP parser of that vendor might have a different syntax and has some problems, or is expecting the tags in another way. So colleagues of Streampunk, they have this SD poker, and you can use that to test STPs if they really comply to the RFC, and maybe push that then back to the vendors. So you get the STP and then post it to the receiver. The receiver can then calibrate its tunings and enable the receiver. The receiver does an IGMP join, and you have your stream running. And that's basically the workflow of ISO 5. And you can exchange the control system from vendor A to vendor B. Anyone who follows that specification then works. And over there, if you want to have a look later, we have different control panels of different vendors, and they all can connect the senders in that rack or any other rack that support ISO 4 and ISO 5, and can push it to the different receivers we have in that rack. And there's also on the screen, you see the different user interfaces that show you all the ISO 4 resources. So in a dreamy world, when we set up the next interop, we don't really have to type in all these IP addresses anymore if everyone supports ISO 4 and ISO 5, and everyone could just get the information from the central registry. some comparisons, specifically to the audio industry. So we have Ravenna. I don't have a way via Ravenna to configure the IP of a sender, so I usually go to the vendor's or the sender's user interface and configure it. There's protocols to configure it, maybe Ember Plus. The same goes for start and stop, but it's not included in one complete. And it can be for video and audio, so Ravenna uses this RTSP. And the discovery works with unicast and multicast, as it is also based on DNS service discovery. Then we have Dante AES67, where you are limited in configuring your IP addresses. Because it is sometimes generated by it's automatically generated. And so the sender is also always on. You cannot stop the sender. And Dante is, of course, an audio protocol. And the discovery is based on multicast MDNS, so it does not span over the subnet. AES70 is always also connection management included in there, but it's a much larger standard that allows you also to do a lot of control. So you can start and stop the senders and the receivers, and you configure IPs. But AES70 is right now very specific for audio. So to add all the capabilities for video, frame rates and stuff, you would have to add all that information into your AES70 implementation. But the discovery can also work multiple. And as in comparison, ISO 4 and ISO 5 really gives you all the configuration you might need. And you can start and stop your receivers and senders. You can also schedule them for the future. It works for video and audio. Also compressed flows could be included here. And the discovery also works unicast. So that's what John pointed out before. All this MDNS stuff is really restricted and doesn't scale. But if you have DNS implementation, then you can really scale a wide network or campus network or enterprise network. So next would be a plug-and-play workflow, which is kind of something that is not maybe applicable to a large installation like a TV studio, but we also do events. So we go to an event, plug stuff together, and we don't really want to type in an IP address. So what can we do? We add a DHCP server and a DNS server, and this is nothing that needs to be on a big, fat physical server. It can also be a service on your laptop or included in another software. And we add in the address pool in the control system an address pool. Like John pointed out before, you can just add a multicast range for your event if you're sure that there is no one else using this network. You have one central point to give out multicast addresses, and then the devices would plug into the network and register, and they get the addresses via DHCP for their config interface and for the media interfaces. Then they would find the registry and register all the resources. Then your user interface or your control system would find all those resources, see all the senders, and would give out multicast addresses automatically. So you really know what all those senders are sending to, and then you can activate those senders. And then you could populate a control panel or a user interface, a software-based user interface, with all those senders and receivers. And then you can basically just do a drag and drop or patch push destination source buttons, and the control system would just exchange the STP file, and you're really done. And there's nothing more to it. So further steps, big topic is security, and I'm actually talking after Simon, who is giving an introduction in 3/4 of an hour. We need some way to authenticate, because right now ISO 4 and ISO 5 are pretty open, so you could just plug into that rack over there, and if you have an ISO 4, ISO 5 browser, you could stop all the streams, which is okay here, but of course not in a secure TV facility. and this is something we need to add to it. And one word about standards, because the title said standardized connection management. Standards are very good for nailing down vague options in RCs, like we did for 2110, AES67, or PTP. So you have really an exchange of packets, but the timings or the size of the packets are very gray in the RC. So a standard is really good to make all this work. But if you go higher level protocols like connection management, control, it is really hard to push all this in a standard. And if you go through the standardization process of the standard bodies, it might take too much time. So this is why I say ISO 4 and ISO 5 are a specification, and it's not a real standard of a standard body. But if we maybe define an engineering guideline for this or set the timings right in another document, then it's a standard way to do it. But of course, it's not a standard. Yeah, and the standardization would, in my eyes, slow down upgrading the specs. So right now we say ISO 4 and ISO 5 are done and stable, but we already see that we need ISO 6, ISO 7, maybe some other stuff to select audio channels, to make it secure, or even further. And this is a very iterative process, and if we, for all these specifications, would go to a standard process with ballots, comment phase, this would never be finished in my eyes. So the conclusion is ISO 4 and ISO 5 complement 2110 and AES67, because as you might know, in AES67 it's also not really clear how to connect all those devices. A plug-and-play workflow can really work. I know this is nothing that maybe large facilities actually want, but for smaller installations that also happen, like festivals or other rental installations, we need this. And ISO 4 can, on the other hand, also complement larger installations that have legacy equipment and the control system has all the device drivers. But if you plug in the new world, the IP world, then you don't have to write new drivers for new devices. You can maybe use the ISO 4 information. We have some questions in specific implementation details, like John pointed out before. What's the timing of those registries? How do we end up in finding the registries? Most do it here with multicast DNS. We push a bit on this unicast DNS. John is going for DHCP. So there's some details. And maybe an engineering guideline or this full stack guideline of John can help here. A couple of links. There's a documentation page, which is quite good if you need further information. A lot of open source implementations exist for a node. If you are a vendor, you can take a node implementation. There's a registry implementation and also a control system, open source. And there's an NMOS Explorer, which you see over there, which you can get from Real, which helps you also to play with it. Thank you very much.
All right, thank you. Do we have any questions? Evgen.
Arne, when do you think we will see it all in full glory, widely adopted? And if it's not the case for the nearest future, what actually stops vendors embracing that and implementing that on a wide basis?
Some of this is what John pointed out. So, for example, this MDNS topic. So there's, I think, a misconception that even a lot of vendors I talked to still in Wuppertal, they didn't know of this unicast way of finding the registry. And then they talk to Arista, Cisco, Mellanox, all the network guys, and they say, oh, MDNS, I don't like that. So this maybe stops them. So it's a lot of education. So that's what I try with my talks. And then another topic is this in the audio connection management, the channel selection. So right now, when you connect an audio sender to receiver, you don't really know if the receiver is picking up the right channel. If you think of a speaker which has only one channel to play out and it picks up an 8-channel stream, how do you tell it to pick up one channel? And this is nothing that needs to be in ISO 5. So like we say, ISO 5 as a complete connection management is done. But to give NMOS as a system into all the products, there's some voices that this is needed. So we are working on that in a new proposal, and then I guess then we can have much more energy.
Yeah, and Evgen, one thing I would say is that the AMWA is trying to work at this iteratively, rather than just bang out a whole load of work and then the industry has to wait and long time and then we bang out another big piece of work. So you mentioned the audio channel mapping. We're trying to get that done in the December timeframe, at least ready to go to the AMWA board. There's another piece of work that's essentially how you would do GPIs in this sort of environment. It's a very simple thing when you think about it, but if you push a button and you want to light a light on one of these cameras, how do we all agree to do that in a uniform way? That's a separate piece of work that we can deliver iteratively to build on the pieces of work that are already done with ISO 4 and ISO 5. So I think that when we see adoption, ultimately that will be based on the manufacturers and their demand from the users. But I think it's also up to us as a community, Arne, to deliver the pieces
yes.
and in a cohesive whole, like the piece that John Myatt talked about earlier, so that people are able to get the functionality that they really need in their, out of these sort of deployments.
Mm-hmm. And another point is workshops. So all this was pre-staged in Wuppertal, as you know, and I think it might have been the last larger one-week event we need to connect all the 2110 because it's really mature. So maybe we can make a combined NMOS, AMWA, and JTNM workshop where the vendors don't have to spend a week on doing PTP and 2110, 2030, 21, but can do things like DHCP, DNS, and more the higher level stuff, which works because a lot of vendors have it, but they don't really have the time to make it right. So we had a lot more vendors that could have been part of this demonstration, but it was just not too solid to show it here. But maybe one more workshop would make help than at least doubling the amount, and then the word gets spread more. Yeah.
All right. Arne, thank you very much.